You're listening or watching a full stack Java developer in the crypto space and in especially Ethereum. So most of my life I have been Java developer, and in recent times I started entering in some ways the crypto space, Ethereum to be exact, and the Solidity programming language and how things work. So there are several articles, tutorials and places to get started with the stuff in theory. So after you understood the basics, the there are Ethereum for Java developers on ethereum.org and some Web3J library. You could get started with getting the code, connecting to Ethereum node and so on, and to write some code that executes something on the blockchain. So in today's article, in today's podcast video or article, I will tell you my broader programming philosophical perspective and my own learning curve about it. So, in my own opinion, it is a total mess of architecture if you think of it as a way if you execute some code, if your current projects have been programs that execute code in a linear incremental manner, you'll be totally lost in the architecture and in the ways you need to do so your code get cold. You in general, as a software developer, you should have a clear picture what and when your logic is executed, what code is executed where. If a coder does not know what part of the code is executed where, it is totally gambling with source code changes. So you should have some minimal amount of idea what code where it is executed. And there are big backend systems that are modular and orchestrated in microservices, and many of them are hard to debug exactly for that reason that there are there are multiple microservices, and if there is some problem and if the logging system is not perfect, you will totally lose yourself in the process of debugging. So also the front end development space has evolved a lot. Many of the framework embraced complex architectures, and what code is executed where starts to get a little bit mixed and blurred, and you cannot and sometimes there are frameworks that purposefully try to hide what code is executed where, so they try to make the life of developer easier, and so he could code programs faster. But in some distant way, this makes the programs a little bit less perfect in broader sense. If the coder has not programmed what code gets executed where, it is not optimal. It is not perfect program, and the developer and the user in the end will have less control on what code executed where. But for example, in some business to business applications where the internet is fast it is less of a less of a problem. This so in the in my learning curve, I noticed total mess of technology stacks. Bitcoin is originally written in C++ because it needs speed of execution. This is perfectly okay. Several other wallets, blockchain explorers, clients, blockchain clients, nodes, wallets, and so on are also written in C++. Ethereum also uses C++ in some of the places. The Ethereum protocol has official implementation in Go programming language, and some of the tools around it are also some Go programs. So the tools in the browsers and many of the G apps are coded in JavaScript. So there is a client-side implementation, some browser plugins that try to connect with a blockchain. There are backend implementation of this JavaScript code that tries actually to get reused, that also connects to the backend. So the total picture, you get a total mix of technology stacks that try to do the same things on the client, on the server, and you could totally get lost in the whole process. So Solidity I found I found similar to Java. The Solidity programming language is the programming language that is executed on the Ethereum blockchain. It has the core building block called contract. So instead of object, it has inheritance, definition of basic visibility blocks, variables, and many well-known programming concepts. But when you think of concept as a Java developer, you must think of remote procedure call. You must think of it as web service or some endpoint exposed by the Ethereum protocol and the Ethereum node, not as some low-level building block if you think in terms of Java. So the Solidity code gets compiled to Ethereum bytecode. To be executed on the blockchain, the compiled Solidity program needs to be deployed on the blockchain first, and to be executed by a Java program. If you want to execute your contract, your Ethereum program by some Java code, you need a generated Java wrapper. It is done by Web3j library, or you could do it with raw RPC calls, where things are a little bit wow code. You need to know how things are structured, the inputs, the outputs, and so on. And things get a little bit far away from the object-oriented thinking and the interfacing with stuff. If you are used to Java ways of doing things. Next, Ethereum Wallet is the program caller or executor. So you execute a blockchain app when the code gets attached to a block to a verified and gets verified by the whole network. This network could be your local machine only. it could be the public test environment with temporary and mock data, chains and wallet coins that are spread for testing purposes, but your final destination will be the actual public production visible to all blockchain. To achieve this, to upload, to deploy your code to a blockchain, you pay to the network to encode your code to a block in the chain in some wrapped in some transaction, and you must pay with Ether. So you need a private key with some Ether. You need a wallet, that is the non-tech friendly name. You need a wallet with some Ether that you must spend so you could upload your contract. So after you have your contract on the network, you must pay in some transaction that calls this contract deployed on the blockchain. So there are several payment layers and several layers of blocks and transactions that need to be processed when to achieve the network to execute your code. So you could call the Java server. You could compare your Java server as Ethereum node client. You cannot and you don't interact with the whole Ethereum network in an obvious manner. Instead, you actually hit a remote procedure call of the Ethereum node. And here are the options for Ethereum nodes that you could hit. You could download and execute a full node and contribute to centralization. And to run a full node, you need a local copy of the whole Ethereum blockchain, and you actually append changes to your local version, and you wait your local node to synchronize with the full Ethereum network that is torrent-like. This is the whole idea behind the blockchain, and after it gets verified. Currently, Ethereum uses proof of work, so it needs processing from all the nodes that do the complex math behind proof of work. And after it all executes, after it all passes OK, at that point your code gets executed on the blockchain. So the full Ethereum node is getting bigger with time, and you should have fast internet connection, and you should have a lot of space, SSD hard drive, and good computer. But thankfully you don't need specialized hardware like the Bitcoin miners for now. So hopefully after the migration of the Ethereum node to proof of stake, you will need less and less there will be less and less requirements to the full Ethereum node, or at least the computing power. So the second option is to use a node client or light node, or a node that keeps only the headers of the blockchain and actually connects to some distant full node. And this is some like semi-delegate, semi decentralized way of running a node or code or so-called client, and let some other participants actually store the full node. And the least decentralized option is to entirely depend on an Ethereum node that belongs to someone else. And this option is in most cases limited to some number of calls to the Ethereum node. This is their business model, limiting you as a developer, as an application developer, to some certain number of calls onto the actual public Ethereum node or network. So at this point you probably get the big picture, how much work and how much layers of code you actually need to fill to get things decentralized. You need a Java program that or a browser program that connects to a node that appends and signs transactions to the blockchain that needs to be get verified, and that node must be synchronized with the public main net, production net, and after the validation of this net, then the code gets executed. So you get the total picture of how much work and how much effort it requires to get things decentralized.